Okay, so we're continuing our journey through section 4.5. What you see on your screen right now is the second pre-class worksheet. This is 4.5b. And in this worksheet, I think it's pretty short actually. I think there's basically one problem. But the problem is a different type of problem. It's a problem where instead of you being given the formula and asked to graph, you are given the graph and asked to find the formula. So in other words, we are given this picture that you see right here, and we want to find, as it says down here, it says the graph above is a sine graph that has been transformed. So we want to find this the function a times sine bx plus c plus d that would give me this graph. So basically we need to find a, b, c, and d. Now this, I had spoken in the last video about d being the vertical shift. We haven't actually seen an example of that, but this problem actually does have a vertical shift. So let me just make a note. This is the first time that we've seen this, but d is a vertical shift. So it slides up or down. All right. So how do we start? Well, as you see in the problems here, the first thing that the problem asks you is to find the amplitude, the period, the phase shift, and the vertical shift. So that's what we're going to do. We're going to find the amplitude, the period, the phase shift, and the vertical shift. It's kind of like working backwards. So we find these guys, and then we use that to find A, B, C, and D. So the amplitude, and this kind of necessitates a slightly different approach, but the amplitude, another way to think about that is it's the distance between the max minus the min divided by 2. So the max, and you see the max is any of these high points because they're all the same height, and the min is any of these low points because they're all the same depth. And so the max would be, what is that? That's 2. And the minimum is 1, 2, 3, 4, 5. That's -6. So 2 minus a -6 over 2 gives me 8 over 2, which is 4. So my amplitude is 4. So what that means, and what I can, what I can kind of sort of stair step off of that in this way, because if my amplitude is 4, if I count down from the high or up from the low 4 units, I will be at like the center line of the function. So if I go 1, let's say we start here and we go 1, 2, 3, 4, that right there is the center of my function. Okay, that's the axis of the function about which it oscillates. Okay, now that's useful because that actually helps me to see the vertical shift. Because the vertical shift initially, we were here on the x-axis, and now I can see that I have moved down 2 units. So my vertical shift would be -2 because of what I just said, which is, after marking this dotted line, I basically just counted how far away from the x-axis I was and in which direction. So, so now I've got my amplitude and I've got my vertical shift. Now let's think about the phase shift in the period. Actually, let's do the period first. Doesn't really matter. So we kind of have to draw a period on the picture so that we can determine our start and stop and everything. We have to pick a start. So that red dot right there, remember this was a sine function. So I'm going to use that as my as the beginning, and then I'm going to basically let this red line that I'm trying to draw here, that is going to be my 1 cycle. Okay, that's my 1 cycle Okay. All right, so how long is that? So if it starts at, so we start at pi over 6, which, by the way, that also tells me my phase shift. If I'm starting at pi over 6, that means I have a phase shift of pi over 6. I'll write that down in a second, though. But so if I start at pi over 6 and I stop at pi over 2, okay, then the period is going to be the stop minus the start, which would be pi over 2 minus pi over 6. And that simplifies to be pi over 2 is 3 pi over 6. So 3 pi over 6 minus pi over 6 is 2 pi over 6, which is pi over 3. Okay. Now, what I said about phase shift, let me go back to that because we actually, have the phase shift as well. So my phase shift would be positive pi over 6. Okay. You could, depending on what you decided to see as your interval, as your fundamental period, you might have a slightly different formula. So there are actually alternative right answers here. So for example, I could have chosen to start right here, and that to be my beginning, which would give me a slightly different formula. I didn't do that, though. I chose what I chose. But I just to mention that there is more than one right answer to this problem. Okay, so we have our amplitude. Let's write it all down here. Our amplitude is 4. Our period is pi over 3. Our phase shift is pi over 6. And our vertical shift was -2. Okay, so now we're going to use the formulas. So the amplitude equals absolute value of A. In this case, you can see that we do not have a reflection. This hasn't been flipped over. Or at least I'm not looking at it as being a reflection. I'm looking at this being my start, so that wouldn't be a reflection. So my point being that I know that this is going to be a positive 4, okay? So A is positive 4. All right. We already found that the vertical shift, that's just going to be D. So D is actually just -2, so there's nothing to do there except to write that down. Now, for B, we're going to use the period formula. So the period equals 2 pi over absolute value of B. We are going to assume that our B value is greater than 0 here. And that way I won't have to think about this absolute value. But anyways, so my period is pi over 3. And I'm going to solve now for B, which gives me, I'm going to basically I'm going to multiply by B and then multiply both sides by 3 over pi. And that would give us 2 pi times 3 over pi. And pi's cancel, and that's 6. So B equals 6. Finally, phase shift is -C over B. Our phase shift was pi over 6. And we found B to be 6, so this is -C over 6, which means that C is equal to -pi. Okay, So putting it all together, our formula would be, kind of squeeze it in down here. Let me get a different color to write with. Our formula would be f of x equals 4 sine of 6x minus pi minus 2. As I said, there are alternative correct answers depending on what you chose as your cycle, but that is one correct answer. Okay, so that gives you an example of the other kind of problem in section 4.5, which is the constructing the formula problem, constructing the formula from the graph. Okay, I'm going to pause the video here.